Now we're going to talk about something a little technical, and while we do so I think we'll go for a little drive. Truth is, I've already arrived. The vehicle is sitting on the dyno tuner at Steve's Auto Clinic at Vanderbijl Park. And the reason why we're here is that I have a quest to improve this vehicle's fuel consumption. The lovely thing about a big fat petrol engine is just the joy of driving it, the power off-road, the power in dunes, but the penalty one pays is high fuel consumption, and this engine, 4.5 petrol, is no exception. And what we're going to do today is discover how they improve the fuel consumption. The principle is to help the head breathe faster, more efficiently, get more air through it. And it begins with valves. This is a standard valve, and this is the valve that is put into the new head. Now you can see very clearly the shape, the profile of the valves are very different. And looking at it, it doesn't seem like it would make a hell of a difference. Well, the difference is enormous. So all in all, if you have a look here, you'll see the head, the way it is being ground out, and how smooth now the inside, the areas where the air will have to move at high speed, how it has been smoothed out. In terms of the valves, here are the two valves. These are the inlet valves. There are 12 of them. And the new valve is actually quite a bit bigger, about 2 millimeters, the orifice 2 millimeters wider, and that multiplied by 12 is quite a bit of air. And the exhaust gas valves, there they are there. And all they've done is they've made it a lot lighter. It's the same size, but they have shaped it again so that the air can escape from the engine faster. And what they've also done is they've changed the camshafts. Now the camshafts time the opening of the valve. Now be careful here. Performance specifications are one thing, but look carefully at the torque. For a vehicle that's going to be driven off-road, you don't want all the power to come through at high RPM. So what I've selected to do is not change the exhaust cam. In other words, the timing of the exhaust valves will be the same as in the standard vehicle. The standard engine is absolutely magnificent at driving at really, really low RPM off-road. It's remarkable, and I don't want to lose that quality. But allowing the engine to breathe is going to give me much more power at high RPM and much better fuel economy. Of course, the question is, how much difference can that little shape change actually make to the efficiency of an engine? It's actually extraordinary how much it can actually make. This machine here, which we're now going to play with, tests the efficiency of an orifice. When an engine works, the piston pulls down, it sucks in air through the induction manifold, past the valves, into the head of the cylinder. The speed at which that air can flow, if it can flow faster in and out, the engine will perform better. This machine we have here is a flow bench tester, and it will, for example, show us how efficient this port is. Now you would think, logically speaking, that, well, it's only so round, only so much air can pass through this orifice. Not true. Watch this. We're first going to see how efficient it is with the rough side, that's the squared off side, on top. So the air has got to be sucked down through that. Right, now what we do is we make sure that we compare apples with apples, and we set it at 10 inches of pressure. And at the moment we're getting, this is the percentage of the setting, we're getting 50 basically, in case you didn't hear that, they sit here at 180 CFM. They then adjust, the machine is then adjusted at 10 inches. That basically means that when we test one against the other, we're comparing apples with apples. It'll be now turned over. It'll stay at 180. We'll adjust it to 10 inches of pressure, and we'll see what percentage of 180 can now travel through that same port, turned around now with the smooth edges. Again, we adjust it to 10 inches.
It takes a couple of hours for the reconditioned head to be assembled. In this case, a brand new head had been put together for me. The old head, now removed, sees wear from about 20,000 kilometers. The new head is all clean and sparkling. Another few hours, with some men grappling under the hood, and the engine is ready to run again. It all went very smoothly, a job which looks far more intimidating than it really is. Here on the Dyna, all wheels are rotated. Being a full-time four-wheel drive vehicle, all of the wheels must rotate. If they don't, the Dyna can cause serious transmission damage. The next thing to do is to remap the DASTEC Unichip, the piggyback computer that controls the engine.